Okay, we continue with the International A-Level Statistics S2 paper from January 2024, and this is question number 2. The length of pregnancy for a randomly selected pregnant sheep is D days, where D is normally distributed with mean 112.4 and variance sigma squared. Given that 5% of pregnant sheep have a length of pregnancy of less than 108 days, part A, find the value of sigma. So we're told that probability of D, the number of days, to be less than 108 is 5%, which is 0.05. Using the standard normal distribution, this is equivalent to probability of Z less than 108 minus 112.4 over sigma. That's equal to 0.05. So we, because the probability is 0.05, we go to the percentage points of the normal distribution table, and we see that probability 0.05 is here, and the Z value for that is 1.6449. But we notice that because here 108 is less than the mean, which is 112.4, therefore the Z value will be negative. So that means that 108 minus 112.4 over sigma, instead of the Z value 1.6449, we'll write the negative of that, which is minus 1.6449, and from here we calculate sigma to be 2.67 to 3 significant figures. Part B. Queen selects 25 pregnant sheep at random from a large flock. Find the probability that more than 3 of these pregnant sheep have a length of pregnancy of less than 108 days. So we define our random variable. So we say let J be the random variable, number of sheep out of 25 with pregnancy less than 108 days. Since we have selected 25 pregnant sheep, so we have n number of trials, which is 25, and the sheep have been selected at random, so they are independent of each other. Therefore, we have a binomial distribution. So J is binomially distributed with n equals 25, and probability is as given in the question, which is 5%, which is 0.05. And we need to work out the probability of J more than 3, so bigger than 3. Since we are working with a binomial distribution, which is discrete, therefore this is the same as probability of J bigger than or equal to 4, and that's the same as 1 minus probability of J less than or equal to 3. So we go to the binomial cumulative distribution table with n equals 25, and probability is 0.5. So probability is 0.05, and we want less than 3, so less than 3 is there, so it's 0.9659. So we have 1 minus 0.9659, which is equal to 0.0341 to 3 significant figures. Part C. Charlie takes 200 random samples of 25 pregnant sheep. Use a Poisson approximation to estimate the probability that at least 2 of the samples have more than 3 pregnant sheep with a length of pregnancy of less than 108 days. So we define a random variable. We say let t be the number of number of samples out of 200 where more than 3 sheep out of 25 have pregnancy of less than 108 days. So from part B, we know that the probability of having more than 3 pregnant sheep with a length of pregnancy less than 108 days was 0.0341. So probability is 0.0341. That's from part B. Now, since n, which is 200, is large, and the probability which is 0.0341, that's why we can use a Poisson approximation, but the question specifies it itself. So we know that what we can do is that we can find lambda in this case. Lambda is n times p, and that's going to be 200 times 0.0341, which is 6.82. And we know that T has Poisson distribution with lambda equal to 6.82. So we want to find the probability of T. It says at least 2, so we want probability of T bigger than or equal to 2, which is 1 minus probability of T less than or equal to 1, since we are working with Poisson distribution, which is a discrete distribution. And that is the same as 1 minus probability of x equals 0 and probability of x equal to 1. We can use either calculator or the formula. Here I'm using the formula, and I'll get 1 minus, so the formula for Poisson distribution is e to the power minus 6.82 times 6.82 to the power 0 over 0 factorial plus probability of x equals 1 is e to the power minus 6.82 times 6.82 8 to the power 1 over 1 factorial. And after plugging it into the calculator, we'll get 0.991 to 3 significant figures.